Aloha, this is a real quick tutorial on how to use Excel to analyze and visualize the data from our antioxidant analyses of plant extracts. Okay, so what you're going to do is open up Excel, which is a spreadsheet that allows you to do that. It's ExcelQuickTutorial, and it's in your Microsoft Office. So you open that up, it's going to ask you to create something. You're going to want to create a blank workbook, or you're going to want to use the template that I've already attached to our Google Classroom. So let's take a look there. It's called Antioxidant Analysis 2020. Okay, so what you're going to want to do is you're going to want to type in, I've already done this to make it easier, type in your data. So this is the data from one of the student groups for inhibition of DPPH, 61% inhibition, 59.3% inhibition, 59.5% inhibition. Remember, we did these in triplicate. And what we want to do is we want to use Excel to calculate the average of these values. And we also want to get an idea of error called standard, I'll write it out for you, standard deviation. Okay, those things. That gives us an idea of the swing around the average. For example, let's take a look at our average. Okay, so over here, what I'm going to do is click on this cell, and I want the Excel program to calculate the average for me. So two ways I could do that. I could insert a function down here, or more quickly, I could just click on this button, which is Insert Function. And all these functions show up over here. And notice that the most recently used ones are the ones that we want to put in, average and standard deviation. I'm not sure what yours will say, but you can do all kinds of stuff with this. Notice you can do lookup tables with if-then types of things. You can do hyperlinks. You can calculate payments based on a certain kind of interest rate that you put in there. You can do all of that. Okay, so we want average. I'm going to insert that function. And look, the computer guesses correctly that I want the average of these highlighted areas here. Okay, so I can control that. So I'll just press return, or you can press done over here, boom. And there's my average, right? Makes sense. The average is about 60 when you have these values over here, right? Okay, so what's the standard deviation? Likewise, I'm going to click down here, and I'm going to insert a function. The functions will come up here, and I want standard deviation. I'm going to insert that one. Okay, this time the computer doesn't guess correctly, right? It's trying to put my average in there, and that's a different value. I just want these values, right, which is my raw data. I want the standard deviation of those. I'm going to correct the computer there, press return, and there's my standard deviation. As you can see, the deviation or error is very small. All of my numbers are tightly clustered around the average 60, so you might expect that these are small numbers. Okay? So now we want to make a graph out of all of this stuff. Here's how you do it. I want to make a graph of the average, right, as instructed on the rubric. And then what I want to do is I want to insert something, and I want to insert a recommended chart. This is how easy it is. Hey, how about that chart? That's pretty much exactly what we want, right? It's just unlabeled, rather. So what you're going to do over here is you're going to go to Add Chart Element, and this is where you can add your labels, right? So maybe I'll add over here that what this is showing is it's showing percent inhibition of the DPPH radical, for example. Okay, and I'll put get rid of all this other stuff. Yeah, and likewise, by adding chart elements, you can add your error bars, like down here. You can add your standard deviation, right? And something will pop up, and add those there. You can click on anything on the chart. You can change the chart title into something more appropriate, for example. Okay, so pretty straightforward. That is how I set up this one that we saw right here, right? I changed the title around. We did various things like that. Okay, I set up a separate sheet with the phenolic data, and I got this gallic acid standard curve. Once again, I put in the concentration, I put in the absorbance, I just inserted a recommended chart. Oops, I didn't highlight it. Let's say this stuff. A recommended chart, and sure enough, there it is, right? So that's how I did it. Okay, so if you look up the gallic acid activity standard curve on the internet, you'll see that the relationship between absorbance and gallic acid concentration is actually linear. It kind of goes like this. It's not supposed to top off like this. So what we're seeing here as it tops off is the limitations of the spectrophotometer actually to tell the difference between different colors at a certain point. Yeah, it's not really actually the relationship or something like that. Okay, at least that's what Dr. Lee said. It's not a saturation of the actual solution that causes the topping off, but rather a limitation of the spectrophotometer. Okay, so that's how I did that. So you can go ahead and click on those. It's actually pretty user-friendly. Click and use around. Alternatively, you can use this spreadsheet that I attached to our Google Classroom, Antioxidant Analysis 2020. And you can just like highlight the data that's there, delete it, put in your own data, and it should populate a already made graph that's already here if you don't want to make your own. Okay, good luck. This is exactly what I was going to go over during the Zoom meeting. So if you can't make the Zoom meeting, this should help you to be able to get this part of your data analyses done. Okay, thank you so much. Aloha.